Start it, sir. Hi guys, so we are going to start. Nana fan appa. Akadu picture. Hi guys, so we are going to start. We are going to start the TOC PYQs marathon. Yesterday I have done some questions, but today we are going to solve all the remaining questions. Okay, and some of the questions I have already solved in the class. So those questions I am not going to solve here because you have already seen them in the paid classes, right? So only those questions which are not solved in the paid question, which are very simple, I will solve here. All the difficult questions anyway I have solved for the paid users. All these are very simple questions. I just want it to be complete. Okay, that's why I'm doing it. Okay. Okay. Answer this question. I'll give you 3 minutes of time. For every question, I'll give you 3 minutes of time. Please write your answer in the. Why is it moving? అరే ఇంపోర్ట్ ఎలా చేసావు దీన్ని? పీడిఎఫ్ కదా నీకు చెప్పింది. నేను వచ్చేదాకా ఆగవా? వెయిట్ చేయవా? పీపీటీ ఎవరు పెట్టమన్నారు నిన్ను? ఇది ఇప్పుడు ఎక్కడ ఆఫ్ చేయాలి? ఏం చేయాలి? ఎవడు పెట్టమన్నాడు? నేను చెప్పా వస్తున్నాను అని. మళ్ళీ రీస్టార్ట్ చేయాలి సిస్టమ్ మొత్తాన్ని. నేను నోట్ 3 ఓపెన్ చేయరా, ఇంపోర్ట్ చేయరా ఫైల్ అని క్లియర్గా చెప్పాను. డౌన్లోడ్ చేసావా ఫైల్? పీడిఎఫ్ డౌన్లోడ్ చేసావా, పీపీటీ డౌన్లోడ్ చేసావా? పీడిఎఫ్ డౌన్లోడ్ చేయి. నీకు చెప్పాను నేను వస్తున్నానని, ఆగదు నీకు. సరే తర్వాత మోడిఫికేషన్ తర్వాత చూసుకుందు కానీ. వాట్సాప్ లాగిన్ అయిందా? పీడిఎఫ్ పంపించు ఫస్ట్ దీనికి. పంపించారు పీడిఎఫ్? అవును నేను చెప్తానని చెప్పా కదా, నీకు అంత తొందర ఏంది, అడవుడేంది? గుడ్ మార్నింగ్ ఎవ్రీవన్. గుడ్ మార్నింగ్ దివ్య, గుడ్ మార్నింగ్ కేవీకేఆర్ రెడ్డి, గురువర్ధన్ గుడ్ మార్నింగ్, సుదర్శన్ గుడ్ మార్నింగ్. గుడ్ మార్నింగ్ ఎవ్రీవన్. బ్రో ఓకే ఓకే. ఏం చేసావు? డౌన్లోడ్ చేసావా? మళ్ళీ నేను చెప్పకుండా చేసేస్తా. ఏం చేసావు ఇక్కడ? ఇంపోర్ట్ చేసావా? ఇంపోర్ట్ ఫైల్ and then choose the file. Always do that. This is the remote where you can go like this. Okay, so this side and this side, just open wherever we are starting. ఇప్పుడు ఏడు మరి మా అందరికీ టైం వేస్ట్ నీ వల్ల ఇప్పుడు. ఎంతసేపు పడింది భయ్యా 2 minutes అన్నావు ఓకే You don't know what questions we solved yesterday, right? This question was done yesterday, right? You don't know that. This question was also done yesterday. This question was done yesterday, right? Last question. Okay, sit down. Mukesh is asking, I have completed my syllabus in 3rd year and give the plan to revise. I forgot the subject and also 3rd year. Just register my course. You will be able to do well. Okay. Okay. Fine. See this. Consider the following two statements. If all the states of NFA are accepting states, then the language. Okay, you do it. I will give you 3 minutes time. You are the one who is going to write the GATE exam. So you are the one who is going to answer this. I'm giving you 3 minutes time. Solve it. Okay. Send a request to me. Okay. So solve this. If all the states of an NFA are accepting states, then the language is like sigma star. How funny it is. How can let me show you an example. Okay. Let me say sigma equal to a comma b. Okay. I can draw any NFA. I will not put a final. Okay. Let us say I'm putting a final state and I'm putting a. What is the language accepted by this? A star. It is not accepting sigma star, right? So this is false. This is false. Can you answer the next one? So there exists a regular language A such that for all the languages B and A intersection B is regular. I will take, there exists a regular language A. I will take A equal to 5. Okay. Now I will take 5 and I will intersect with any language. Okay. Then I'm going to get 5 and it is regular. So we have A. So 2 is true. So only 2 is true. Okay. Anyway, we have solved all these questions in the class, but I'm still revising them. Okay. Do this question. I'm giving you three minutes. Okay. Do this question. I'm giving you 3 minutes. So in Epsilon NFA, I have given you how to do this question. It's a simple question, just time taking question. Okay. It is just time taking question. Done now. So I think you have to put some hobbies and other stuff. Just fill them. Put it 100%. Okay. Hello, sir. అయిపోయింది అయిపోయిందని చెప్పండి నేను మాట్లాడతాను ఒక్క నిమిషం నేను ఫోన్ చేయిస్తాను వాడికి లైన్లో ఉండండి సార్ ఒకసారి హలో ఒక్క నిమిషం సార్ ఓకే 3 minutes are over. I will give the hint how to solve it. Okay. So whenever epsilon NFA is given, you have to find out something called epsilon closure. Okay. So I have discussed in the class. See, whatever I have already discussed in the class, I am not going to discuss in YouTube because that will just waste your time, right? So see, whenever a string is given in epsilon NFA, you should add epsilon closure to it, right? So how are you going to solve this one is, how are you going to solve it? See, one thing is don't use this table. This table is going to be a little bit bigger. Okay, don't use this table because you'll get confused. Draw the state transition diagram. That is the first thing. And then now that you want ABC, ABA, right? Now that you want ABA, you can write epsilon closure here, epsilon closure here, epsilon closure here, epsilon closure here. Now do it. I'll give you 3 minutes of time. We discussed in the class already all these things. Everything I discussed in the class. I didn't leave out anything. Okay. Take it. See, sometimes what happens is, especially in TOC, there will be only two kinds of questions. One question is you don't have to use pen and paper. Other question is it will be so much time taking. TOC is really very interesting subject. For some questions, you don't have to put pen and paper, but for some questions, you have to really work hard. This will take at least 5 minutes of time. I mean, we can do in 2 minutes, If I explain, it will go take 5 minutes of time. Okay, try it everyone. Try it guys. Try it. సార్ రాలేదంట వాడి నెంబర్ పెడతాను కాల్ చేయండి సార్ ఒకసారి వాడికి ఓకే సాల్వ్ ఇట్ ఐఎమ్ గివింగ్ యూ సమ్ టైమ్ Take 3 minutes of time. Do it slowly. See, while practicing, I will give you any amount of time, but I want the correct answer. Okay. I'll give you any amount of time. Now it is not gate exam. Do it properly. Okay. I'll give you any amount of time. Do it properly. I'm giving you 3 minutes of time. Do it. Okay. Okay. So see, the thing is, you should choose exactly when to use a state transition table and state transition diagram. I can tell you for 90% of the questions you use state transition diagram, it will be easy for you to understand what is happening. See, if I give you a table like this, you will not understand what the language is accepting. But if I give it in a state transition diagram, that you will understand. Okay. So it is not a hard and fast rule, but in TOC, you will be able to answer questions accurately. 90% I can say. 90% of the questions you can answer accurately if you use state transition diagram. So let's convert this into state transition diagram. Okay. So how many states are there? Q0, Q1, Q2, Q3, right? So let me write it here. Q naught, Q2, Q naught, Q1, Q2, and Q3, right? Now can you fill the transitions there? Try to fill the transitions in this, right? Okay, fill it, then you will be able to answer it easily. So Q naught on epsilon is going to Q2, and dash is given, which means this is the initial state. On epsilon it is going to Q2, and Q naught on A is going to Q1, and Q naught on B is going to Q naught, right? And Q1 on epsilon is going to Q2. Q1 on epsilon is going to Q2. And Q1 on A is going to Q2. Q1 on the A is going to Q2. You can write a separate one or you can write comma A. Well, let us write like this, okay? Okay. And Q1 on B is going to Q3. And now let's look at Q2. Q naught on epsilon is going to Q naught. Sorry, Q2 on epsilon is going to Q naught. Q2, is it right? Q2 on epsilon is going to Q naught. Is it right in the question? Just check the question if there is something wrong. Q2 on epsilon is going to Q naught. Right only, yeah? Okay. And then Q2 on A is going to 5, not going anywhere. Q2 on B is going to 5. Q3 on epsilon going to 5. And Q3 on A going to 5. And Q3 on B is going to Q1. Sorry, Q2. Just check if I am right. Huh? Am I right in this diagram? Okay. Now what is that they are asking? Delta denotes the transition function. I told you, right? Delta is the transition and delta cap is the extended transition function. See, if you want to find out, let us say state A on the A. If I write like this, what is it? State A on the A, where is it going? Now if I write a extended transition function, then instead of writing a symbol, I can write a string like this, right? Now what is that they are asking? Extended transition, this one function. Can you do it now? So whenever epsilon NFA is given, I told you how to find out. You have to write epsilon closure everywhere, and we discussed what is epsilon closure in the class. I'm not going to do it now. Okay, epsilon closure, and then A, and then epsilon closure, and then B, and then epsilon closure, and then A, and then epsilon closure. Okay, this is how you are going to write. Okay, now what is the start state? So they have given delta cap of Q2ABA. Q2, is it right? Q2 only, yeah, or Q naught? Delta cap of Q2ABA. Q2 means you have to start from Q2. Fine, I'll start from Q2. Now find out what is the epsilon closure of Q2. What does that mean? What are all the states that Q2 is going on epsilon? Okay. So if you observe it, Q2 on epsilon is going to Q1, right? So definitely Q2 will be there in the epsilon closure, and Q2 on epsilon is going to Q naught. Q2 on epsilon closure is going to Q naught. And also you have to check if Q naught is going somewhere on epsilon. So Q naught on epsilon is going to Q2 only. So only this Q2 and Q naught. Okay, fine. Now Q1 on A. Q1 on A is going to Q2 on A is going to Q1, right? No, this one. Q2 on A is going to Q1, right? I done something wrong, huh? Q2, right, opposite side, yeah. That's why these are silly mistakes that we can make. Q2 on, we have to say A, not going anywhere, right? Q2 is on A, not going anywhere. Okay, fine. They can find 5. And what about Q naught on A? Q naught on A is going to Q1. Okay. And 5 anyway it is dead. Don't worry about it. Now find out the epsilon closure of Q1. What are all the states that Q1 is going on epsilon? So definitely Q1 will be there. That is for sure. Epsilon closure of any state is the same state. Epsilon closure of any state is the same state. Okay. So give me some sunshine. So Q1 is giving me Q1. Now Q1 is going to Q2 as well. Okay. On epsilon it is going to Q2. And again Q2 on epsilon is going to Q naught. So you get Q naught also. Right? Right? Now on B, we have to see on B. Okay. Let me write all these states above. Okay. Q naught, Q1, Q2. I'm just writing all these states above. So here we have got Q naught, Q1, Q2. Now Q naught on B. Q naught on B is going to Q naught only, right? And Q1 on B, no transition. Q1 on B has no transition. Acha, Q1 on B has Q3. Okay, this is what is confusing. Okay, and then Q2 on B. Q2 on B, no transition, right? 5. Okay, good. Now find out epsilon closure of all this. Now you might have already found out epsilon closure earlier. See if you have found out epsilon closure of Q naught earlier. I think you have not found out epsilon closure of Q naught. So now find it out. So definitely in Q naught there will be epsilon closure mein Q naught will be there. Right? And Q naught on epsilon is going to Q2. Q2. And Q2 on epsilon is going to Q naught. It is already there. Fine. Now on the A, Q naught on the A, just see Q naught on A. Q naught on A is going to Q1. Q naught on A is going to Q1. And what about Q2 on A? Q2 on A, it is not going anywhere, right? So it is dead. Now what about Q1 on epsilon star? You might have find it out somewhere. Just see if you have found out somewhere. Here I didn't find. Acha, here I have found out Q1. Q1 ka epsilon star is Q0, Q1, Q2. We have already found out. So I'm directly writing it. See, try to reuse it. Don't do it again. See, here you have already found out Q1 ka epsilon closure, which is Q0, Q1, Q2, right? So finally, we are going to get Q0, Q1 and Q2. So answer is Q0, Q1 and Q2, right? Right? Consider the following language. Okay. W ends with substring 011. Which of the following deterministic automata accepts W? We have done this, right? Substring is 0, 1, 1. You can do it fast. We have done, I think, hundreds of questions in the class. You should be able to answer it. Okay. Take 3 minutes of time and answer. Okay. So 0, 1, 1 should be W ends with substring 0, 1, 1. You can directly do this, right? So you have to end with 0, 1, 1. Okay. If I get a 0, if I get a 1, if I get a 1, I'm going to end it. Okay, I'm going to accept it, assuming that this is the last 0, 1, 1. Let any number of ones come, I'll wait for 0. Okay. Now, if I get any number of ones, not a problem. That is still ending with 0. Actually, it has to end with 0, 1, 1, right? So, if I get a 1 here, the sequence is spoiled. I will again go back and wait for 0, 1, 1. So, this state is complete. Now, here if I get a 0, I have to go back and wait for, if I get a 0 here, I have to wait for 1, 1, 1 only, right? If I get a 0 here, I have to wait for 1, 1 only, right? Right. Now, this state is complete. Now, coming to this state, if I get a 1, again entirely I have to wait for 0, 1, 1. Okay, so if I get a 1, I will wait for 0, 1, 1. If I get a 0 here, if I get a 0 here, then I have to wait for 1, 1. Right? Check which option is suitable. Okay. In the options, is it red? Is it there in the options? It is not there in the options. Huh? D is the option. Huh? Okay, fine. D is the option. Okay, it is there in the options. Something is missing here. Huh? Here I can get zeros, right? So this here I have given only what for 1. I didn't give anything. So let me put 0 here. Because any number of zeros can end with 0, 1, 1. 1 here. Okay, here. Here I have to put a 0. Okay, you can do it. This is a simple question. I'm not going to do it. Okay. Next. Consider the following deterministic finite automata. The number of strings of length 8 accepted by this. How many number of strings of length 8 are accepted for this? Take 3 minutes of time. Okay. Light So 8, right? 1, 2, 3, 4, 5. So 2 chances, 2 chances, 0, 1, 3 number path, right? 0, 1, and then 1, 0, 0, 0, 1, and then 1, 2, 3, 4, 5, 2, 2, 2, 2, 2, and then 1, 0, 1, 5, 0, 1, 2. This is how much? 2, 1, 1, 2, 3, 4, 5, 6, 2 power 6, 2 power 6. This is how much? 2 power 6, and then 1, 1, same, right? 2 power 6, 2 into 2 power 6, right? So 2 power 8, and 28, 2 raised to 4. Okay, so how many 8-length strings can be possible? This is not a actually TOC question, this is counting question. You have to count, okay? And also, there is no other way to count it other than exhaustive counting, okay? So we have to do exhaustive counting. Fine. So if you observe it, 0, 0 followed by something is there, right? So 0, 0, it can be followed by 0 or 1, right? And then these are 3-length strings, 1, 2, 3, 4, 5. So here there can be 0 or 1. Here see this 0 or 1. Here there can be 0 or 1. Here there can be 0 or 1. Here there can be 0 or 1. Now 0, 1. 0, 1 followed by 1, 2, 3, 4, 5, 6. 0, 1 is followed by 0, 1 followed by any number of zeros or 1. So 2 chances, 2 chances, 2 chances, 2, 2. Here also 2 chances, 2 chances, 2 chances, 2 chances, 2, 2, right? Now what about 1, 0? So 1, 0 also has 2 chances, 2 chances, 2 chances, 2 chances, 2 chances, 2 chances. What about 1, 1? See this, 1, 1 also has, here it has 2 chances and here it has 2 chances because it is just 0 or 1. 2 chances, 2 chances, 2 chances, right? So this is nothing but 2 power 6. This is also 2 power 6, 2 power 6, 2 power 6. So how much is it? 256, right? 4 into 2 power 6 is 256, right? Answer this question. Answer this, take 3 minutes, okay? Okay guys, this is nothing but minimization ka question. Okay, so this is the DFA, you have to minimize it. See, whatever data they have given here, that is just useless. Okay, what finally they are asking is, when you try to minimize them, how many states are together and how many states are not together. That's it. Okay, this is a minimization question. I'm not going to do it, you do it. So the answer is B and C. 3 and 4 are distinguishable, 2 and 5 are distinguishable. How are you going to do this? You are going to take 1, you are going to write pi naught. We discussed it. Pi naught is going to be 1. In the class, I told you this. Okay, 2, 3, 4, 5. Right, I will show you 1. I'll show you 1. Right, so let us check 3 and 4. So 3 and 4 on 0. Let's check 3 and 4 on 0. 3 on 0 is going to 1. Okay, and 4 on 0 is also going to 4 on 0 is also going to 1. Now 3, 4, let us check on 1. Okay, now 3 on 1 is going to 2 and 4 on 1 is going to 5. Is going to 5. Right? Right? Now you have to check for all of them. So when you have these many, first you check for two states. So see this. 2, 3, 4, 5 is there. You check all 5, 4C2. 4C2 means 6 combinations you check. Right? Right? And it is going to be lengthy. Then you are going to get B and C. See, how to do this? We have already discussed in the class, but I will just discuss it, okay? I'll just discuss it here, okay? So, what is pi naught? Pi naught is 1, right? And then 2, 3, 4, 5. Now there is only one state, don't have to check it. Check 2 and 3, okay? 2, 3 on 0. 2, 3 on 0, right? Now 2 on 0 is going to 3, okay? And 3 on 0. 3 on 0 is going to 1. So 1 is going to 1 and other is going to 3. Separate partitions. Therefore, 2 and 3 have to be separated. Then you take 4, 5, check if they can go with 2 or 3, and then check 4, 5 also. So this is a lengthy question, minimization question. You will get the answer. Okay, you will get the answer. I'm not going to solve it. It's just a waste of time, right? It's just a waste of time. Lengthy question. Answer this question. Take 3 minutes of time and answer this question. Very good. Most of you have answered it. Most of you have answered it. ఇది కాదు తెమ్మంది. ఇది పోయింది. చూద్దాం. Okay, guys. So, how are you going to answer it? See, don't use Arden's lemma or don't use the state elimination method. The problem is, if a language is regular, there can be infinite number of regular expressions. Okay, if you use state elimination method or Arden's lemma, you will get a regular expression, but there is no guarantee that that regular expression will be in the options. Only way you can do it is by elimination, no other way. I can still derive all of this, but it is going to take one whole day. If you want, we can see already the session is going to be till 9 o'clock. If you want to stay till 12 o'clock, I can do that. Okay. So let's try to eliminate. Okay. So what is this, guys? This is odd number of ones, right? This is odd number of ones, right? So this looks like it is generating odd number of ones. Let's keep it aside. Okay. Now can this generate odd number of ones? See, if I put a 2 here, if I put a 0 here, then what do I get? 1 0 star 1 1 followed by 1 0 star 1 1. Now if I put a 0 here, I will get 1 1 1 1 1 1, which means even length strings are coming. This is not the answer. This is not the answer. Right. Now what about this one? If you check this, I can generate two ones. And one is anyway there, which is an odd number. But the problem is, I will not be able to generate a string like this 1 0 0 1 1. I cannot generate it. See, 1 I can generate, and after that I cannot generate two zeros followed by a 1. Only 1 0 is there. See, now the question is, sir, how do you know how to solve it? It comes with practice, nothing else. I have solved thousands of questions, so I can answer any question. You solve thousands of questions. Only in TOC we have given 1,000 practice questions. 1,000. More than 1,000, I guess. It would be 2,000 or 3,000 questions only in TOC. You can start taking the tests. Now, what about this one? It is also going to generate even number of ones. Okay, so what I will do is I will put a 0 here and I will put a 2 here. Then what happens? 1 plus 0 star 1 0 star 1 followed by 1 plus 0 star 1 0 star 1. Now, if I concatenate these two, I get 1 1, which is a even length, right? So C is not the answer, D is not. That is how you eliminate. A is the answer, right? But the only problem that you may face is when there is none of the above. Then you have to work hard a little bit. You can answer it, but you have to work hard. Okay. Now answer this question. Answer this question. Take 3 minutes of time. Take 3 minutes of time and answer this question. Okay. Okay, so let me solve it, guys. Again, don't try to convert the finite automata into a regular expression by using state elimination method or Arden's lemma. Again, I'm telling you, again, I'm telling you, again, I'm telling you, for a regular language, there can be infinite number of regular expressions. So, don't use any method to convert it into regular expression. Try to eliminate. Okay, try to see what what is the language accepted by this. See, by looking at this state transition diagram, you should be able to guess what is the language accepted. That's it. Okay, so here if you observe it, it is accepting 0 zeros, not accepting 1 zero, accepting 2 zeros. So we are accepting even number of zeros, see, in fact this is a finite automata for even number of zeros and this is a finite automata for odd number of ones, and we are just combining them using the epsilon. So the language is even number of zeros and I can write or because it is a union of two finite automatas, one union, other union. I can write or. So even number of zeros or odd number of ones. Now I have given you hint. Can you solve now? Take 3 minutes and solve it now. 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 So we have already discussed in the class that regular languages are closed under union, and I told you two methods, okay? And I told you two methods, right? See, when there is a regular language, let us say L1, regular language 1, you will get a regular expression for it, right? And when you take a regular language 2, you will get a regular language 2. Now, if I take union of these two, it is nothing but regular expression 1 plus regular expression 2. So, regular languages are closed under union. Now, one other way that we discussed in the class was by taking the finite automata, right? So, let us say there is a finite automata for L1. Let us say there can be any number of states. I am just giving it as an example, okay? Let us say there is finite automata for L2. How do you take union of this? Add a new start state, and you put epsilon here and you put epsilon here. That is what they have done. This is even number of zeros, odd number of ones. They have taken union. Union means OR. Okay. So any string which has even number of zeros or odd number of ones should be accepted. Any string which has even number of zeros or odd number of ones has to be accepted. Now, what is the problem with first one? It is cool, even number of zeros and odd number of ones. But the problem is there may be a combination which it may not accept, right? So if I want a combination 0, 0, 1, I cannot generate it. Even number of zeros and odd number of ones. So A is not the answer. Actually, with practice, I know that B is the answer. Okay, but let's eliminate others. Okay, let's eliminate C. Now you may ask, why are you eliminating C? Because that is with practice. Okay, okay, okay. So, what is the problem with C? What is the problem with C? Even number of zeros, it can generate even number of ones. It can generate even number of ones. What I will do is, also you can eliminate it in a simple way. Epsilon is there in the language, right? See this. Epsilon is accepted. Epsilon is there in the language. Even using that method, it is even simpler. What is the minimum string in this? You put a 0 here, you put a 0 here, you put a 0 here. After you put all these zeros also, you get 1. Epsilon is not there in the language. You can go by that method. Or if you want one more method, you can generate even number of ones. How? You take this, and again you repeat this, and you repeat this. Now what about this one? Here also the same thing. If I put a 0, 0, the minimum string generated is 0. The minimum string generated is 0. So all the three are eliminated. So B is the option. In such questions, they will give you only elimination type of questions. Okay. 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 Janni Vazda has sent chocolates, huh? They are in the hostel. Vazda sends me chocolates every day, and because of her, I have increased my weight at least by 2 kgs. Every day she sends me 2 Mars. Every day without fail, morning 5 a.m. I get 2 Mars, and I like chocolates a lot, especially Mars. So after waking up, I have 1 Mars, and before sleeping, I have 1 Mars. My wife doesn't order any chocolate. I mean, she doesn't allow me to have chocolates. but Vasta sends it to office, and at office I have it. Okay, fine. This is done, right? Okay. Answer this question. Consider the following DFA defined over alphabet sigma equal to a comma b. Identify which of the following is or are accepted by DFA. We have solved hundreds of questions in the class. We have solved hundreds of questions in the class. Take time, no problem. Take time and answer it, okay? We have a lot of time. Take time and answer it. It accepts set of all strings ending with the pattern BAB, right? It accepts set of all strings ending with the pattern BAB. If you have any doubt, you can draw it, okay? It has to end with B, A, B. If you get a BAB, assume that that is the last part of the string and accept it. And accept it. Any number of A's may come, you just wait for a BAB. So this is done. And here A is done, B is not done. Any number of B's may come, it will still end with BAB. So this is done, A and B. Now what about this? B is done, A is not done. If I get any number of A's here, that will be BAAAB, right? So again you have to wait for the entire BAB. So go back and go for entire BAB. Now after BAB, now after BAB, see how did we reach this state? Assuming that the BAB that we have seen is the last one. That may not be the case, right? I may get a A. If I get a A, I have to again wait for entire BAB. I have to wait for entire BAB. And if I get a B, I have to wait for AB. If I get a B, I have to wait for AB. So this is complete, this is complete. See, one interesting thing that I want to tell you, but I'm very afraid that you might by heart it and make some mistakes in some other questions. One important interesting shortcut is wherever there is a loop on A will go there, and wherever there is a loop on B will go there. See this? A is coming here, A is coming here, and B is coming here. And this happens only with ending with pattern. This happens only with ending with pattern. Okay? Fine, I don't want you to do such things. You can draw it directly. Why to have any shortcuts? Why to have any shortcuts? Okay. So some people are asking for MSQs. We have lot of MSQs and numerical answer types. Challenging test series is going to contain only MSQs and NATs. There is no such test series in the world, at least in India. We have only MSQs and we have only NATs. It will be very, very difficult for you to solve. It will be very, very difficult for you to solve. Right. Answer this question. Answer this question. So what I was saying is, we have solved this kind of problems long back. I mean, in the class, we have solved this kind of problem. Even without looking this PYQ, I have solved such questions. Don't think that after looking at a PYQ, I solved the question based on that. No. You are getting all the questions from my notes. You can check my 2012 ka notes that will have this problem. But it is asked in 2004. That's okay. Fine. Okay. Okay, let me solve this. You are not able to solve it, let me solve it. Okay. See, they have just renamed. What is K? K is set of all states. And this is actually sigma. Sigma is A comma B, which means input alphabet is A comma B. And C. What is C? Q sigma delta. Okay. So instead of writing delta, they have given C, which is a transition function. and S is the start state and F is the final state. Final state is B and start state is A. And they have given you the entire transitions. There are only two states with transitions. See, whenever they have given you transition function or transition table, try to convert it into transition diagram, state transition diagram. Convert this into state transition diagram, you will be able to answer it within seconds, right? So, A, see, instead of delta, they have used row. In some of the textbooks, they have used row. There is a textbook by Shanti Kumari, and she has used row in that. That is a standard textbook. She has used row instead of delta. Okay, and Ullman and Peter Lynch, they have used delta only. So you should not be sticking yourself to the symbols. Symbols may change. They may change any symbols. Okay. Okay. Fine. See this. Capital A on small a is going to capital A. And we know that starting state is A. Okay. Capital A on small a is going to capital A. And capital B on small b is going to B. Capital B on small b is going to B. And capital B on small a is going to B. And capital B on small b is going to A. Right? And then it is given that final state is B, which means final state is B. That's it. Now, what is this, guys? What is the language accepted by this? Odd number of B's. The language accepted by this is odd number of B's. Now, this is a finite automata, and in the options they have given you right linear grammar. It is so simple. I told you how to convert a finite automata to right linear grammar, right? So, write the rules. A on seeing A is going to A, or on seeing B is going to B. On seeing B is going to B, right? Now B on seeing A, B on seeing A is going to B, or B on seeing B is going to A. Now since B is the final state, we are going to add epsilon. You can check the options, right? So what is the option? B is the option. B is the answer, right? Now answer this question. Consider the NFA shown in the diagram. Some NFA is given in the diagram, okay? Oh, there are no final states, huh? Can you check if there are final states in there? NFA doesn't have final states. Huh? No final states, huh? So state X is the starting of the N. Let the language accepted with, okay. They have intentionally given it. State X is the starting state of the automata X. Let the language accepted by an NFA with Y only as accepting state is L1, and the language accepted by NFA with Z as the only accepting state is L2. What is the relationship between L1 and L2? We solved this model in the class. This question is asked in 2005. Okay. Try this. We have solved it in the class. Take time. Take time and solve it. Okay. Take time and solve it. Don't rush up. I want correct answers, not fast answers. Okay. This is a very small question. In the class, we have solved a very big question. This is a simple question. In the class, we have solved very big question, right? What was the question we solved in the class was, we had, if you remember it, I have solved this. 1, 2, 3, 4, 5, 6. I have taken 6 states and done this. This is just a 3-state wala. If we have solved this 6-state wala, this is just a cakewalk, right? So this is an application of Arden's lemma. Okay. Now what is that they are saying, guys? What is that they are saying? If X is the starting state, then the language accepted by NFA is L1. If Z is the starting state, then the language accepted is L2. Write down. L1 means we have to solve for Y. Y is the final state. Solve for Y. Now L1 we have to solve for Y. Right? Y equal to X on 0, we are getting it, right? Plus Y on 0, we are getting it. Y plus Z on 1, we are getting it. Z on 1, we are getting it. Right? Now coming to Z. Now L2 is final state is Z. So write down the equations for L2. So Z on 1 is going to Z. Okay, cool. Now X on 0 is going to Z. Cool. Now Y on 0 is going to Z. Now if you solve both the equations are same. See this. X0 is here, X0 is here. Y0 is here, Y0 is here. Z1 is here, Z1 is here. Now when you don't solve them. Now don't write the entire Arden's lemma and then R equal to P plus ST. All that is not required. You have to come to the answer quickly. Both of them are giving the same equations. If you solve them, you are going to get the same languages. So A is the answer. Okay. Answer this question. Consider a NFA shown in the diagram. Some NFA, this is same one. Okay. Consider the regular grammar. Some regular grammar is given where S is the starting state and set of all terminals, which means sigma is given as A, sigma is A, and the set of non-terminals is, there's a small mistake. S dash is not there, right? Can you check this question? There's a small mistake in this question because in the grammar S dash, no S dash, right? So yes, W, X, Y. Yes, W, X, Y, Z. Okay. We wish to construct a deterministic finite automata, DFA, to recognize the same language. Then they are asking what is the minimum number of states required in the DFA. We have solved hundreds of questions like this in the class. Try, take time and answer. No need to give the answer first, but your answer should be the best. Being first is not the priority here. Being the best is the priority here. Okay. Have it. Height. We have solved same question. Right side. Then I'll take one more. Okay, fine. Let's draw the finite automata. What are the states? There is S, there is X, there is Z, there is Y, there is W. Now S on A. Okay, so it is a right linear grammar, right? I think we have to convert it to left linear grammar first. Okay, it is a right linear grammar. We have to convert it into left linear grammar and then do this. Otherwise, you can do a simple procedure. Otherwise, you can do a simple procedure. I'll tell you a simple procedure. See, how do I come up with simple procedures with practice only, right? See, X is just giving ZA, right? Right. So I can substitute X there. So S derives ZA, A. And Y is just giving WA. So Y derives WA. S derives WAA. WAA. And then Z derives SA or epsilon. And then W derives SA. Can you solve it now? Can you solve it now? Try to see what is the language generated by this. Try to see what is the language generated by this. Okay. So S derives ZAA and Z derives SA, and where are we going to stop it? Z derives SA. Now again you can take, or you can stop it here also, right? Epsilon, which means you are getting 2 A's. Or if you go with WAA, right? And W is going to give us SA, and S is going to give us ZAA, and Z is going to give us epsilon, right? 1, 2, 3, 4, 5. So if you see this, A power 2 will be generated, A power 5 will be generated, A power 8 will be generated, A power 11 will be generated, so on, which means all these are number of A's in W is congruent to number of A's in W is congruent to 2 mod 3. We have solved so many questions on this. We have solved so many questions on this. And the answer is going to be 3. How? 2 mod 3, right? So this is remainder 0, this is remainder 1, this is remainder 2, right? 0, 1, 2, 0, 1, 2. Don't count B's. I think there is no B at all. It is just sigma is A, right? So sigma is A only. Okay, A. Now 2A's have to be accepted. 1, 2, 3, 1, 2, 1, 2, 3, 4, 5 is accepted. 6, 7, 8 is accepted, right? So this is the finite automata. That's it. 3 states. Solve next question, please. In the automata given, S is the start state and T is the final state. S is the start state and T is the final state. Consider the strings U equal to U. There is something wrong. I think it is V, right? This is V. How many ever times we check there are some errors coming up? So U, V and W, which of the following statement is true? Which of the following statement is true? Solve it. Take 3 minutes of time and solve it. Solve it. So everyone has solved it. This is a stupid question. I'm not going to solve it. It's not my. Okay. So answer is D. Okay. Answer this question. Consider the DFA in which S0 is the start state and S1, S2, S3 are final states. Okay. So what is they are asking? What does this one accept? This is a grid machine. I have given you RBR method. Use RBR method and solve it. Use RBR method and solve it. Sir, lunch break, please. Very hungry. 30 minutes lunch break. How many of you want lunch break, guys? I too didn't have lunch. When I have work, I forget everything. How many of you want lunch break? Please say yes. How many of you want lunch break? Please say yes. Okay, many people want lunch break. Okay, so I will give you 15 minutes of lunch break. What is the time now? Okay, I will give you break at 1:45 till 2 o'clock. Okay, lunch break will be from 1:45 till 2 o'clock. Solve some few questions and then we'll take it. Okay. Okay. So you can apply RBR method here. This is a grid machine, right? If you are confused by looking at like this, just tilt it. Okay. Just tilt it. Okay. Just tilt it, then it will be easy for you. So S0 is here, S1 is here, S2 is here, S3 is here, right? And S0 is the start state. And horizontally we are counting x's, S3 to S2. Horizontally we are counting the x, and vertically we are counting y. So S0 to S3, see this. Vertically we are counting y. Vertically we are counting y. Vertically we are counting y. Now what are the final state, guys? S1 and S3. S1 and S3. Use RBR method. Use RBR method. What is RBR method? Draw lines. So we need this state and this state. So I will draw a line here and I will draw a line here. Then S1 will be the final state. So what do you understand from this? So if I draw like this, I cannot say anything about x, but I can, if I draw like this, I cannot say anything about x, but I can say something about y, right? So y is always even. We are discussed in the class, right? Even wise. Y is always even. Now if I draw like this, if I draw like this, I cannot say anything about y, but x is always odd. Odd x. So even number of y's and odd x, or because there is one more state, right? Draw a line like this, draw a line like this. Okay. Okay. Now this is giving me odd number of y's. Odd number of y's. This is giving me odd number of y's. And if I draw like this, it is giving me even number of x's. Even number of x's. Check the options, okay? We will get it. Try to answer this question. Shall we take the lunch break? Now it is 1:40. We'll take lunch break till 2 o'clock, okay? Lunch break till 2 p.m. Okay? Because this question is going to take some time. Let's take lunch break by till 2 p.m. Okay? Come back exactly at 2. Huh? I will start. Come back exactly at 2. Come back exactly at 2. Okay. C is there. Huh? Okay. Consider the following finite automata P and Q over alphabet A, B, C. Okay. A, B, C is given. The start states are indicated by double arrow, but we have used single arrow, and the final states are by double circle. And let the languages be denoted by A of P and A of. Hello, sir. Hello. అది ఇందాక మిస్డ్ కాల్ ఉంటే చేశాను, నేనే మిస్డ్ కాల్ చేశాను. అది నిన్న నైట్ మెసేజ్ పెట్టాను, అవ్వలేదు. మీరు కాల్ తీయకపోతే నైట్ మెసేజ్ పెడితే అది మెసేజ్ పెట్టారు ఇప్పుడు. సరే రేపు చూద్దాం అదైతే. ఓకే సార్, బాయ్. అయిపోయిందా? ఓకే సార్, బాయ్ సార్. నేను పెట్టనులేండి సార్, నిన్న మీరు లిఫ్ట్ చేయకపోయేటప్పటికి పెట్టాను. అదేలేండి, నో ప్రాబ్లం సార్, పెట్టను ఇంకా. ఓకే, సారీ సార్, సారీ. లేదు సార్, నో సార్, నో సార్. ఓకే సార్, ఓకే సార్, థ్యాంక్ యూ సార్. ఓకే. Okay, so what is the question? You do it, no? You take 3 minutes and do it. If I say everything will be spoiled, okay? Okay, try it, guys. Sudarshan, very good, Nana. Sudarshan, very good. Okay. Many people have got A. See, don't try to analyze what is P, what is Q, and what is the intersection. Right. Now you have to find out intersection. This is all going to be very complex. These are meaningless questions just to confuse you. Right. So, how can you solve it? Try to find a string which is in both of these languages and see that that string is not in one of the options, and you keep on eliminating. That is the best way to solve it. Right? 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 Okay. So, if you see this, A is accepted. Acha, one thing, epsilon is accepted, right? Epsilon is accepted. Epsilon is everywhere. See this? Epsilon is accepted, epsilon is accepted, epsilon, epsilon. So, epsilon we cannot do anything. Now, see A. Is A accepted? A is accepted here, and A is accepted here. Here also A is accepted, A is accepted, A is accepted, A is accepted. We can't do anything. Let's see B. B is accepted here, B is accepted here, so it is in the intersection. Now here also B is accepted, B is accepted. Here B is not accepted, you can delete it. Right? B is not accepted, right? And here B is accepted. So we are able to delete one option. Now epsilon AB are over. Let's check AA. Now if you observe it, AA is accepted here. A is accepted. So we have AA here as well as AA here. Now check which of them are giving AA. So here AA is accepted. Okay. A and A. Here A is not accepted. So cut it off. Check this. This is already over. A is not there. Cut it off. So answer is A. Don't solve it. Don't apply intersection method. Okay. If you have to apply intersection method, it will take 1 hour time. 1, 2, 3, 4, 1, 2, 3, 4. Totally we have 16 states. And so you will get 16 final states. And then you have to minimize it. Then you are going to get 4 states. And in the minimization, you have to check it. This is the textbook procedure for intersection. 4 into 4, 16. And all are final states. So all are 16 final states. When all are final states, minimization is very difficult. After minimization, you are going to get 4 states. And then you have to check the option. Right? Right? Don't go by textbook methods, okay? Textbook methods are for BTech exam. If the same question is given in BTech exam, you cannot apply this method, they will get surprised and shocked. You cannot say epsilon A, B, A. You have to do the entire procedure. But we are not preparing for semester exams. We are preparing for GATE CS. What is CS, guys? What is CS? What is CS? Okay, solve next question. This question we solved in the class. I'm not going to solve it. This question we solved containing AA or BB. We solved many questions on this. I'm not going to solve it. Take the answer. Answer is A. And again, this question, A, B, B, also we solved in the class. So I'm not solving it. You solve this. DFA is given. Final states and non-final states are exchanged. Which of the following? So read the question. Take 3 minutes and answer it. Take 3 minutes and answer it. Okay. Take 3 minutes and answer it. Okay. 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 What is the answer, guys? So try to see when sometimes you will be able to understand the language by looking at the finite automata. So this is set of all strings ending with AB, right? A, B. If I get one more A, I will wait for a B. If I get a B, I will wait for entire AB. Any number of A's can come. If a B comes, that is ending with B. And initially any number of A's. So this is what? Ending with AB. Ending with AB. And this is a DFA, right? See this. A, B are there, A, B are there, A, B are there. So this is a DFA. And I told you that when you complement a DFA, the language is going to get complemented, right? So what is it? It is ending with AB. So it is nothing but complement is nothing but set of all strings that do not end with AB. Complement of all the languages that do not end with AB. Okay. Answer the next question. If the final states and non-final states in a DF, the same question. Okay. Consider two finite automata, M1 accepting L1, M2 accepting L2. Which of the following is true? We solved many questions like that, hundreds of questions, hundreds of questions, hundreds of questions. I'm not going to solve it. Some people are saying B. Are you saying B really? Are you crazy? Pratibhandu, what happened to you? Divya, what happened to you? Is answer B? Some people are saying B and D. Take time and do it. Take time and do it. Oh, there is a typo here. Okay, there is a typo. This is not the final state. Final state only, yeah. Even if it is final state, you will get B only. Yeah. Check it once. This is not final state. No. Sorry, guys, you are right. This is not the final state. Okay. Not the final state, no? There is a typo, okay? Not the final state. Very good. Very good. See, what is this? This is the DFA for set of all strings containing 1 1. Containing 1 1. And this is NFA for set of all strings containing 1 1. So both are equal. Languages are equal. Okay. Cool. State whether the following statement is true or false. A minimal DFA is equivalent to an NDFA with n state has always 2 power n states. Always 2 power n states. Very good. It is false. Not every minimal DFA will have 2 power n states. I'll just give you an example. Okay. Let us say, okay, this is a NFA, set of all strings ending with A. Now, if you try to draw the DFA, minimal DFA, set of all strings ending with A, set of all strings ending with A, you are going to get this. See this? 2 states in an NFA and in minimal DFA also 2 states. So, this is not always true. It is the worst case. In worst case, you can have 2 power n, but it is not always true. Nana, తీసుకో, take it. Nana, తీసుకో. Don't waste the food. Okay. This question, these models we solved like anything. We solved all these models together. You should be able to answer it. Take 5 minutes time and answer it. Even if you know the answer, still practice it once, okay? Just practice it. Practice it once, everyone. Take time and practice. This is a practice session, not exam, okay? Take time and practice. Okay. So everyone got B5. I'm not going to do this. Okay. I'm not going to do this. We have done it in the class, right? What is that? A simple question. Deterministic finite automata. Last two symbols are same, right? So you are going to get A plus B star followed by AA or BB. Okay. So you are going to get AA and you are going to get BB. Just fill the missing edges. That's it. Right? 5 is the answer. Now there is this question also we have done it. This is a simple stupid question. Okay. Let's skip it. You want to do it. If you want to do it. So 0 plus 1 n times is there. Minimal state. One more thing you have to understand is minimal state finite automata. Whenever they say minimal state finite automata, it is always NFA. NFA will have minimum number of states. This question is not about DFA. This question is about NFA because NFA has minimum number of states. Minimum number of states, right? NFA will have minimum number of states. Okay, cool. N plus 1 is the answer. Maximum number of states in a DFA. What is the answer for this? You don't have to use pen and paper, right? We have solved this in the class. Very good. So maximum is B 2 power n. What was the example I have taken to prove this? Lost string from R. I have taken the example and proved this, right? So what was the example? Second symbol from the ending is A. Third symbol from the ending is A. Fourth symbol from the ending is A. For this, if I am getting order of n states, for minimal DFA, I am getting order of 2 power n. For minimal DFA, I am getting order of 2 power n. Order of 2 power n. Again, the same. The same question. A's are divisible by 6, B's are divisible by 8. Grid question. This is a grid question, right? This is a grid model. What is the answer? We have solved hundreds of questions on this model also. Divi, very good. Divi is answering very fast. Sudarshan, very good. Aishwar, Vardhan, very good. We have solved even complex questions. Number of A's are at least 3, B's are divisible by 6. We have solved a lot of questions on that. So it is D, right? Answer this question. This is done. The smallest finite automata which I said, length is divisible by 3. Answer this. Don't take a lot of time. Answer this. See, this is summer, no? Keep having buttermilk. This is summer season. Keep having buttermilk, okay? And mangoes, of course. Okay. Yeah, so the answer is B, divisible. Answer this. We have solved it in the class. How many states are you getting? Answer it. We have solved it in the class. Answer this. Okay, how many are there? 40. How many questions are remaining? Hmm. 150 slides are there. Very good. So answer is D. Answer this question. Number of zeros and number of ones in W are divisible by 3 and 5. We played with this model. We played with this model of questions, right? How many? 15, right? 15. Next. Answer the next question. They are asking you to minimize it. They are asking you to minimize it. See what is the answer you are getting. They are asking you to minimize it. It is very hot outside. Summers, you can't live without AC in Hyderabad. At least for May, June, July is somewhat okay, I guess. Rains will start almost in July. May, June, we cannot live without ACs. May, June, like hell. What is today? May, yeah? May 20, 24. One more month and it will be beautiful in Hyderabad. Okay. Yeah. So everyone got C, C, yeah. B, right? There is no dead state here. This state is unreachable. Remove this. This state is unreachable. It is not dead. Now, if you observe it, you don't have to apply the algorithm also. See, any number of B's I'll be here. Once I get a, I will go into this. Once I get a, I will enter this Padma view. Okay, like how Abhimanyu has entered Padma view. We are going to enter Padma view, and we are never going to come out. Okay, and we are going to accept any string, right? So simply you can write like this. Don't apply the algorithm also. Simply you can write like this. Simply you can write like this. Right? Two states. Or if you are not able to follow this, textbook method is do minimization. Okay. What is the number of states that accept substrings? N. Yeah. N plus 1. True. Solve this, everyone. See, what they are saying is, let us say there is a string A, A, B, okay. Now every substring has to be accepted, which means epsilon is accepted, A is accepted, AB is accepted. So n plus 1, C. Answer this question. K is a constant. K is a constant. So epsilon is not, okay, I will not say, you answer it, okay. If I keep solving, what are you here to do, right? I'm not going to solve it, you solve it, okay. We are solved enough. Epsilon is not there in the language, so you get plus 1, right? N plus 1. This is nothing but, what is this? This is nothing but number of A's in W is congruent to N 0 mod N. So you are supposed to get N states, but they have clearly mentioned that K is greater than 0 and N is a positive integer, which means epsilon is not there in the language. So even though you are going to write N states, you have to add one more start state. Epsilon should not be there in the language. You can do that. We did it. Answer this question. DFA is given. Which of the following final state method is valid? Which accepts the same language? Right? I'm not going to solve this. See, you can anyway, these are the final states, two final states behaving the same. You can combine them two and then try to minimize. I'm not solving it, okay? So answer is you are going to get A. Now answer this. A intersection B. L of M intersection L of N. Okay. Only one person has answered, it is 5, right? See, this is what? Ending with A. This is set of all strings ending with A. This is set of all strings ending with B. If you take intersection between these two, see what is this? Set of all strings ending with A. This is set of all strings ending with B. Set of all strings ending with B. Now if I take intersection, that will be 5. Okay. Options are not given, huh? Nana, options are not given, Nana, here. Huh? Here options are not given. Huh? Options are missing. Oh, it is numerical type. Huh? Then, oh, the number of states in the minimal DFA. Okay, so 5 means, see, there should be at least one state. 5 means this. Answer is 1. Numerical answer type. Ending with 1 0. Try this. Numerical answer type. Numerical answer type. This is numerical answer type. This is numerical answer type. Okay. So what is that you are getting? 3. Everyone got 3. I will not do it. 3 is the answer. Set of all strings containing 0, 0, 1, 1. We have solved it. Let language be this. What is the minimum number of states in DFA? You have to just complement it. What is the answer you got? We have solved many such models here. I'm not going to solve it. Okay. 5 is the answer. What is this? Answer this. అరే ఇది నా కోట ఇక్కడికి వస్తే వేట అన్ని కనబడితే ఇక చూస్తాడు తాట నికల్ నికల్ చల్తే రే నికల్ 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 everyone is answering 2 yeah string length is what is this string length is 1 even if you go by NFA or they asking they are asking for DFA right they are asking for DFA not NFA. See, if they are asked for NFA, you could have directly given like this, right? 0, comma 1, 0, comma 1, 0, comma 1, right? But in order to draw the DFA, you can just modify this a little bit. You can just modify this a little bit. What is this language, guys? String length is at least 1. String length is at least 1. You can write it like this: 0 plus 1. String length is at least 1. Now you draw the DFA. So, string length is at least 1. Done? 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 You can do this. We have solved it, right? We have solved this in the class. Try it. Take 3 minutes and try it. Take 3 minutes and try it. You want to use bathroom? The next room. This room is dirty. he will You will be surprised to see this room. You will never enter. Go to the other room. So what is this, guys? Three states, right? There are two ways you can do it. One way is second symbol from RHS is B, isn't it? Other way is set of all strings ending with BA or BB. BA or BB. What is the answer you got? 3. So, set of all strings ending with B, A or BB. I got 4 states, sir. Huh? Acha. Lost state. You can fill the remaining. Okay. Fine. Answer this question. Take time and answer it. Okay. So what is it? W1 has to be 2 length. Okay. So what is the language? A plus B, W1 has to be 2 length. and then there has to be a and W2 has to be 3 length, which means A plus B, at least 3 length, A plus B, followed by A plus B star. Okay, now you do it. You do it. What is that they are asking? Minimal number of states in DFA is what they are asking, right? So initially this A plus B you put here, okay, and then this A plus B you put here, okay, and then this A you put here, okay, and then this A plus B you put here, A or A comma B, and then this A comma B you put here, and then this A comma B you put here, and then finally it is A plus B star only, right? You can put A plus B star, right? Okay, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. Huh? Oh, it is a DFA, right? It is a DFA. So here you have talked only about A. If a B comes, you are going to kill it. Okay. Here it is not required. It is just any number. Okay. Not required. Okay. This also we have seen 2 power n ka. I am not going to solve it. Oh, this is bisections. This is not from TOC. This is from discrete mathematics. We will solve it later. W does not contain 3 or more consecutive ones. Try it. Try it. Try it. Try it. Complementary method. So they are saying that we have done it in counting also, right? It should not contain 3 or more ones. It can contain 0, 1, 2, right? Okay, fine. So 0 ones accepted. And the language is 0 comma 1, right? So 0 ones accepted. 1 1 accepted. Any number of zeros, right? Here there's small change. After a 1, if a 0 comes, again I have to go back and check if there are 2 zeros or not. Okay. Okay. 2 ones, you accept it. 2 ones, you accept it. Right? And then we are going to have one more state which has more than 2 ones. When we have more than 2 ones, we are putting a dead state. Now you complement it, you get this language. See, what is it? 0 ones, 1 1, 2 ones, 3 or more, we are killing them, right? Now take the complement of it. What is complement? Exchanging final and non-final states. We have seen that in the class, right? No, don't do anything, just exchange zeros and ones. Don't do anything, just exchange zeros and ones. Non-final state will become final state here. Here there is a 0. That's it. Right? 4 is the answer. Someone has answered 8. Oh, 8 was the last question. Okay. It was the last question, right? 8. Okay. Solve the next question. W does not contain. Oh, this is done. This is 2 power n. We have seen it. I'm not solving it. Okay. Solve this question. MSQ. Solve this question. Solve this question. Okay. What is the answer? Everyone has said A and C. Cool. A and C, right? See, this is set of all strings starting with 1, and see, this is set of all strings starting with 1, and this is set of all strings starting with 1 and having any number of ones and then 0. This is having 0 also. In this there is no 0. So this is bigger, which means 1 star 0 is bigger because it has 0, it doesn't have 0, so it will be bigger. And inside it there will be this 1 1 star 0. Okay, cool. You can answer any question, huh? We have solved this in the class. I'm not going to solve it. So here one option is missing, R star, right? We have solved it in the. So let me give you even more. This is also true. A plus B star. There are a lot of formulas. I don't want you to remember all these formulas, but then A star, BA star, right? Not whole star. Whole star is there, huh? Whole star. Okay. And then B star, AB star, whole star. I can write this one here also, right? BA star, whole star, A star. I can write AB star, whole star, B star. Or I can write A star, B star, whole star. Or I can write A star, B star, whole star. Or I can write B star, A star, whole star. Or I can also write A star plus B whole star, or A plus B star whole star. So many formulas. I don't want to mug up all these formulas. They're anyways there. Okay. Sir, next classroom course is there, please. Give update. I want to join with you. Yeah. You can join offline course anytime. I'll make a video about it. Okay. I'll make a video about it. Which of the following regular expressions identities is not true? Just now we have seen, right? You can solve it, okay? In some programming language, identifier is given. Solve it. You solve it. You solve it. Simple only, right? So why is that they are saying any letter followed by any number of letter or digits? This one, any letter followed by any number of letter or digits. Okay. This one we solved in the class. This one also we solved in the class. This one we solved in the class. This one also we solved in the class. Solved in the class. Solved in the class. Just now we seen this. A is equal to B, right? This one is A. Just now we seen it. Solved in the class. Solved in the class. What is this? At least two zeros solved in the class. Even number of ones solved in the class. Solved in the class. Which of the following expressions given represent the GFA? Out of these three, you solve it. It is interesting question. You solve it. It is interesting question. Even though we solved it in the class, we'll solve it. Okay. We have solved it in the class. Okay. Two consecutive zeros and two consecutive. We have solved it in the class. We have solved it in the class. This one also we solved it in the class. This one also we have solved it in the class. This one, we solved it in the class. If you want, you can solve this. Interesting question. Solve it. Solve it. Hello, hello, hello. Okay. Some problem with the mic. This is a right linear grammar, right? First, do the right linear grammar to finite automata, and then you will get the language. We solved it in the class. Huh? No audio. Huh? Hello, hello, hello. Hello, 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 hello. OBS पकड़ लो. Hello, hello, hello. Audio is coming. Hello, hello, hello. Huh? Okay. Turn on the YouTube, okay? Solved it in the class. This one we didn't solve it in the class. Can you solve this one, guys? Solve this one. Myhill-Nerod theorem. Solve this one. Last option. Huh? Okay. Try to draw the. See, Myhill-Nerod theorem is based on minimal DFA. I told you that. Myhill-Nerod theorem is based on minimal DFA. Now, this is a right linear grammar. There are only two non-terminals. So, there are only two states. Yes, S is a state, A is a state. S on B is going to S on A is going to A, and S is a final state. Actually, you don't have to worry about final state also. And A, what is A? Capital A on small a is going to S, and on small b is going to B. Small b is going to B. Right? Now, if you see this minimal DFA, it is accepting even number of A's. But that is not what we want. We want what is S accepting, what is A accepting. Or instead of saying accepting, the better word to use is representing. What is S representing and what is A representing. Okay. So what is S representing? Even number of A's. What is A representing? Odd number of A's. Just see where it is. So there are two Myhill-Nerode classes, equivalence classes. There are two Myhill-Nerode equivalence classes. There are two Myhill-Nerode equivalence classes. You can check the options. What is it? Even number of A's, odd number of A's. See where is A's and A's even number and B's even number. Here A is even, A is odd. This is it. Right? That's it. Regularity is preserved under the operation of string. But yeah, if you take a regular language, DFA, and if you reverse it, you are going to get a DFA for reversal of the language. Yes, we solved this. We have solved with the proof. State which of the following are true. All subsets of regular languages are regular. No. All subsets of regular language need not be regular. Why? Because if I take A star, B star, the A power n, B power n is subset of A star, B star. A power n, B power n is subset of A star, B star. False, right? Regular languages are closed under intersection, closed under union, closed under complementation, closed under clean closure. R1 star is not regular. Yeah, R1 star is regular. Okay. R1 star is regular. Yeah. This is about Turing machine. We'll see this later. Okay. L is sigma star, R is something. L union R is definitely regular. Acha, L union R and R is. So this is not regular. 0 power n, 1 power n is not regular. Sigma star, L is regular. Regular and non-regular. Okay. Stupid question. We have solved it many times. This also we solved it. Tables I have given you, right? This is also stupid question. We solved it. We solved this. We solved it. This is I square. Okay, there is a typing mistake. This is I square. We solved it in the class in the context free languages. This is finite. We solved this in the class. This model I'll solve it. Okay, we didn't solve it in the class, but I'll solve it after I'm done with the context free languages. This is a very interesting model. You'll love this. Many people, almost all the TOC faculty, they ask you to memorize it. because I'm friends with every faculty, right? So we discuss questions. So see, one interesting thing I want to tell you is every person in gate industry is a very good friend of mine. Okay. And whenever we meet over drinks, yeah, I'm a social drinker. Whenever we meet over drinks, we generally talk about the subject. Every faculty of TOC that I met, I know every TOC faculty. See, what is the advantage of me is I teach all the subjects and people teach one or two subjects. So whenever I meet them, I will discuss with that subject. Okay. No faculty has given a right answer for these questions. They ask you to by heart them. There is no need to by heart them. I'm going to teach you this in such a way that by looking at the question, you will come at the answer. You will not by heart it. You cannot by heart it. There are a lot of models possible, right? This one I will do after context free languages. Don't worry about it, I'll do. Anyway, this one is about the table. You have seen that. This one is also a stupid question. In context free, we have seen that. Yesterday only we solved it, right? P is a regular, Q is a context free, and Q is subset of P. For example, some example is given, okay? Then which of the following is always regular? Try it. Try this one. Try this one. We didn't solve it in the class. Try this one. Hmm? See, complement of a regular language is always complement. P is a regular language, right? P is a regular language. If you take the complement of regular language, it is always complex. It is always regular. This one we have solved it in the class. L1 equal to 5, L2 equal to A. Which of the following? This one also we have solved it in the class. L1, L2 star, union, L1 star. So L1 is 5. So this entire part, anything you apply concatenation with 5 is going to be 5. And L1 star is epsilon. So the answer is epsilon A. Right? This is a stupid question which we have solved in the class. This question also we solved. Concatenation of two regular languages. There is a small typo here. A power n and then B power n. Concatenation is regular. And this is not true. See, if I have A power n such that n is greater than 0 and B power n such that n is greater than 0, A power n such that n is greater than 0. If I apply concatenation of two regular languages, it is regular. Why? This is nothing but A star. This is nothing but B star. When I concatenate them, I am going to get A star, B star. But I am not going to get A power n, B power n. Okay. This one I will solve in context free, okay? Something has to be done there. This one also I will solve in the context free. WXWR. I will tell you a method, okay? There is a typo here, right? S1 derives A, S1B or epsilon. So what is this, guys? A power n, B power n. Now S2 derives AB, S2 or epsilon. What will this derive? AB star. So this is regular, this is not regular. See that there are no printing mistakes, huh? Okay. This one I have solved it in the class, but I have to explain something more. I will do that. This is also a stupid question, right? Prefix, suffix, table I have given you. RBR table 4. Number of A's divisible by 2. Number of A's in X divisible by 2, but not divisible by 3. They have to be divisible by 2, but should not be divisible by 3. How are you going to solve it? Try this one. How are you going to solve it? Not divisible by 3 means? Not divisible by 3 means? The remainder has to be 1 or 2. The remainder has to be 1 or 2. Right? Right? For this one, you will get 6. Okay. Number of is divisible by 2, but not divisible by 3. So divisible by 2 means you are going to have this. Not divisible by 3 means you are going to have this. Right? You are going to get 6. Over. Huh? This is based on the table. We have solved this. Case states. We have solved it. If you want, you can solve it also. It is a stupid question only. RBR table 1. Two power n. What is L1? Try it. You try it. You try it. Simple only, no? So what is L1? L1 is A plus B plus followed by A plus B plus followed by A plus B plus regular. And what is L2? L2 is A plus followed by A plus B plus followed by A plus. Same question. This question is solved. And I will solve this model in context free also. You'll understand it. You'll understand it, okay? This is about the properties. We have solved it. Every subset of a regular language is regular is false, no? I've given you example also. Ora? No. Repeat, prefix, suffix, half. Actually, I have not given you half and repeat. Repeat, we have seen it in a different way. W is repeating. Prefix we have seen. Suffix we have seen. Half I think I didn't show you. Okay. I'll show you half also. Okay. A stupid question. There is typo here. 0 power m, 1 power n. And it is a finite language, regular. Palindrome, not regular. Even number of zeros and even number of ones, regular. Okay, guys. So that is all about the PYQs of regular languages. I have left only one question. That question is a combination of sequential circuits with regular languages. Okay. Okay. That's all. And next Sunday, we are having marathon on context free and Turing machines. Next Sunday, we are having marathon on context. Otherwise, next Sunday, we'll have marathon on DBMS. Okay. Or both. So next Sunday, the schedule is 8 a.m. to 12 p.m. marathon on context free languages, PYQs. And let's not give 1 hour break. 12:30 p.m. to 4:30 p.m. Database especially till normalization we'll have a marathon. Okay, sir, how do you keep yourself motivated doing same thing over the years? I'll tell you something. I'll tell you a secret. Okay. Now let's have ask me anything session. Okay. How do I get motivated? Is simple logic. Find out something that you do that you love to do. Okay, see, okay. Okay, do you have time? Shall we do some half an hour ka ask me anything session? Okay. See guys, there are two things in life that you should understand. Okay. I'll tell you a secret which no one told you. Point number one is find something you love. Okay. Find something you love. You love doing. I love teaching. And the second point is make someone pay for it. See, you are doing what you love, okay, and someone is paying you for doing what you love. You never get tired or it will never be boring. Okay, secret. मैं तो secret बता दिया. I have told you the secret. Don't tell it to anyone. That is how you become great in life, right? Ask me anything. Ask me anything. I think my team sitting here is getting tired. Shall I stop it? Okay, fine. I'll stop it. They are tired, extremely tired, I think. I am not tired. I am never tired. Okay. If you want me to continue marathon of DBMS now, I will do it. I used to teach 14 hours a day. 14 hours with just half an hour break. Because I get money, right? Why would I not do it? My team is tired. Let us give them a break. Okay. And again, what is the DBMS is at 8 p.m., right? So 8 p.m. we have DBMS. And the concept is some foreign keys ka just a simple concept is remaining, and then we are going to go for normalization. We know how to find out candidate keys, alternate keys, super keys, foreign keys now. Okay, then we will do normalization. Very interesting and easy one also. Okay, end it. Thank you guys. See you.